Hello, I'm going to talk about Euler's equation and Euler's identity. Euler's equation, it relates an exponential expression to a trig expression. E raised to the power I times theta equals cosine of theta plus I times the sine of theta. I, in this case, is the imaginary number. E is Euler's number, approximately equal to 2.718. And then theta is the Greek letter that kind of looks like a football that we use in trig to represent our variable. So e to the I times theta, theta is the variable there, equals the cosine of theta plus I times the sine of theta. If you remember from studies of the unit circle, cosine on the unit circle is associated with the x value of a point, and sine is associated with the y value of a point on the unit circle. So the expression cosine of theta plus I times the sine of theta is going to give you a real number plus I times a real number, a plus bi. This is a complex number and is the exact coordinates on the xy plane where the point is that is being discussed, the theta, the angle, giving you that point on the unit circle. So it relates a complex number a plus bi from the unit circle to an exponential equation e to the I theta power. This equation is extremely important in a lot of technology. It's used in all of electronics. Without this extremely powerful equation, we would not have the technology we have today. The mathematics are too complicated in any other form. So it's extremely helpful. Moving forward to the Euler identity, if we plug a specific number in for theta, we get a really cool expression. That number is pi, the irrational number 3.14, etc. If you plug pi in for theta, on the left side of our equation, we get e to the I times pi power. So that has e, I, and pi, three really interesting numbers. On the right-hand side, let's plug pi in for theta. You would get cosine of pi plus I times sine of pi. So the cosine of pi, that's the x value of the angle pi, which is 180 degrees. The x value over there is -1. So cosine of pi gives us -1 plus I times the sine of pi. Sine of pi, that would be the y value over at that 180 degree point. That would be 0. You're not up or down at all. I times 0 is 0. So that whole part goes away and we just get -1. So we have the equation that e to the I pi equals -1. Adding 1 on both sides gives us e to the I pi plus 1 equals 0. That is the Euler identity. It has all these really important numbers in math and science. E, the Euler number, I, the complex number, pi, the ratio of any circle's circumference to its diameter, plus 1, which is the multiplicative identity, equals 0, which is the additive identity. That equation, e to the I pi plus 1 equals 0, is really important and really cool. And when you think about that equation, you could think about all those different numbers, what they mean, where you've heard of them before, and how cool it is that they all come together in one equation.